Okay, so chain rule. Okay, so those of you guys need to understand chain rule because chain rule is the most important part. It put everything, all the pieces together because most of the things that you take in derivative is always involved with chain rule. If you're not master at chain rule, then you're not master at derivative. So today is actually more important than everything out there. So I know some people, I think Luke's not here today. So Luke's probably paying attention to this thing. But this is probably the only thing that you have to really, really understand deeply. Because if you don't, then all the derivative is missed. So let's talk about what is chain rule here. And make sure you copy down because you're gonna need this. This is like the only thing that is always tested. If I want to give you a point distribution about chain rule, I would say probably 6 to 8 points on the AP exam. And you only need a 42 point to get a 3. So if you understand this, that's like 1/7 step there. And chain rules apply to on lots of things. So we're talking about 6 to 8 points. So you cannot don't understand this. So the way I kind of told people like how do you recognize when to use chain rule? Usually is the time that you got a function within the functions. So function within the function, or a parentheses. So I don't know how to spell parentheses. I think I know how to spell. With power other than 1. If it's 1, just use power rule. So that's probably the time that I will use chain rule, which is pretty often. Almost like 90% of derivative on your AP exam is going to be involved with chain rule. So if you don't, then you're pretty much screwed. I'm talking about 6 to 8 points minimum. It could be as up as 12 points. Because when sometimes you do an integration, you still need to use chain rule as well. When you take a small derivative.
What are both instances when you use chain rule?
What?
You're saying those are both instances of chain rule where you use.
Yeah, that's probably in general that is. Now, what is composite functions or what is function within the function? So let's just say h of x equal to f of g of x. This is called composite function. So this is a composite function. And they are the example of function within the function because g of x is within f of x. Now, with that being said, what is if the h of x is equal to 1 over x plus 1 to the square, actually to the first, what is the g of x and what is f of x here? If I have this h of x equal to 1 over x plus 1, what is the f of x and what is g of x? Josh? F of x is 1 over x, good. And g of x is equal to x plus 1. Does that make sense? Because if I would have said, what is f of g of x? In this case, I'm going to plug in g of x into f of x. Then it'll be 1 over x plus 1. Is that okay? That's called function within the function. Now I could have another function. I could have h of x here. I could have square root of 2x squared minus 3x. Something like this. Giovanna, what do you think? What is f of x and what is g of x here? What do you think? You gotta try. It's okay. If you got it wrong, it's fine. But you gotta try. If you haven't failed, you haven't tried it. You're the type of student that too afraid to get something wrong. You cannot fear to get something wrong because you'll never get it right. So you gotta be not afraid of getting something wrong. And it's okay, it's wrong. No, I need Giovanna to answer it. Try it. Giovanna? You gotta try it. I'm gonna wait for you. The problem is you guys are too afraid to try. Don't be afraid to try. You got it wrong. Nobody care. I'm not making fun of you, and nobody will make fun of you. Giovanna? Gotta try. You cannot just say, no, I'm not gonna try. I'm not gonna try. No, you gotta try. Nobody care if you got it wrong. Even you told me a wrong answer, I don't really care. So give it a try.
I just don't know how to start.
Okay, think about which functions, what's your function. Think about what's f of x. And think about what's g of x. G of x, to put inside of f of x, it will result into square root of 2x squared minus 3x. And if you told me something wrong, it's okay. I'll just fix it for you. But you gotta be the one to make a mistake first. And it's okay to make a mistake. The problem is you have too much fear to make a mistake. Says I have to do something right. No, you don't have to. Jordan make a lot of mistake on the WhatsApp. I'd never criticize her, ever. I just say, okay, you make a mistake. Let's change it. But stop. Let the fear control you. So you guys told me something because the class cannot move without you saying something to me. And even if you told me a wrong answer, you gotta be not afraid to say a wrong answer. What, you afraid of people judging you? No, you don't afraid of people judging you. Don't give a shit about what other people think about you. Come on. You're holding the class back. Give me the wrong answer. Give me a wrong answer that think in your head. What is so afraid of being wrong? The problem is you afraid of being wrong. 2x minus 3? Okay, that's not bad. That's a good start. Almost. That's actually not bad. G of x 2x minus 3 is actually not bad. You can improve just a little bit. Okay? So, good. You make a mistake. Does that make you feel bad? No, don't feel bad. Just make a mistake. It's okay. I'm trying to tell you, you spend more time on worry about you're gonna make mistake rather actually go do it. So go ahead and make that mistake. It's actually 2x squared minus 3x. You're very close, super close. You're just missing an x. The second one was f of x. Which function you plug in is gonna result this? You got this. It's okay. It's all right. Just Say it. 1 over x squared. Okay, you're almost there. Do you have the square part right? It's actually a square root. Because think about it, let's plug in here. What am I gonna get? This. That's fine. Hey, look, it's a process. You did a good job. Doesn't matter. You have to be not afraid to make mistake. So now I have this. Now you got a two function. There was two layer, right? 2x squared. 2x squared minus 3x to the 1/2. That is the first function. This is our inner function. So inner function is 2x squared minus 3x, which is g of x. And the h of x, f of x is equal to something to the 1/2 power. Now I'm going to teach you how to take a derivative now. In order to take a derivative of this, it's going to be f of g of x. If I take a derivative of this, it's going to be f prime of g of x times g prime of x. Okay, so now we're going to take a derivative now. It's like doing chain rule. It's like doing peeling the onions. Have you guys peeling an onion before? It make you cry, yeah. So derivative of chain rule does not make you cry. Now, if you don't pay attention, it might. So when you peel the onion, you peel the outer layer and you peel the inner layer. The same thing, but the inner layer is still intact when you peel the outer layer, right? Does that make sense? And then you go to the next layer. You go to the next layer. It's kind of like you have bubble gum. There's bubble gum with sour outside, sugar coat inside, and the bubble gum inside. It's kind of like those. You're gonna consume all the outer outside, which is sour part, and the sugar part, and the thing. So if I have this h of x, if I have something that I say 2x minus 1 to the 10th power. Now I'm gonna show you how to do it. Store it. That's a function within a function. The first function is x to the 10. The second function is 2x minus 1. So h prime of x is going to be, just take a derivative of x to the 10. What's derivative of x to the 10? 10x to the 9. But except the x is not x. The inside is still intact. The sugar part is still there, right? 2x minus 1 to the 9. Does that make sense? Now I'm going to take a derivative of the inside, which is the sugar part, which is 3, which is 2. And the answer is 22x minus 1 to the 9. And that's it. Super easy. You draw two bubbles. You take a derivative of the outer bubble and take a derivative of the inner bubbles. Yes?
Where did you get the 2x minus 1?
Because just think about something to the 10th power, right? Something to the 10th power. If I take a derivative, it's going to be 10 of something to the 9th power. And that something is 2x minus 1. Does that make sense? Okay, I'm going to give you one. H of x equal to square root of 3 minus 2x to the 3rd power. I'm trying to say it's other power than 1. A to the m over n equal to n roots of a to the m. Power over roots.
Oh yeah, I remember the tree with the sun.
Yes.
When doing the derivative part, how come it's like
Yeah, because this is the f of g of x. This is the f of g of x right now. And the f of x is x to the 10. So you gotta take a derivative to the outer layer. So x to 10, x to the 9. And then there's a g prime of x, which is take a derivative to the inside. So take a derivative inside is gonna be, because this is a rule. You take a derivative outside and then you times g prime times derivative to the inside.
oh, okay, so it's not just like prime, like f prime, g prime, it's like f prime of g prime, and then g prime.
Exactly. So Can I rewrite this function? Can I rewrite like this? Yeah, so this is just a first algebra rule, right? Now there's inner function. You draw it, guys. Learn how to draw it. Draw the outer bubble and draw the inner bubbles. The outer bubbles are first. 3 over 2 times 3 minus 2x to the what? And times what? There we go, you're done. 2 cancel out, equal to negative 3 times 3 minus 2x to the 1/2. Super easy. Yes.
I can just use square root x instead of x to the 1/2.
What?
Use square root x instead of x to the 1/2.
Square root of x?
Well, you go do negative 3, I mean, 3 minus 2x and a square root.
Oh, square root, yeah, it's fine. Negative 3 square root 3 minus 2x. Yeah, that's fine. Remember we talked about this when you have a constant on the top? Actually, hold on, let me change it a little bit. Remember that's a constant on the top. I always tell you says constant on the top, avoid quotient rule. You can avoid quotient rule by moving to the top and use chain rule. So now I want you to try to use chain rule rather than quotient rule.
There's a new problem.
Yeah.
You have x will equal to that.
Negative 7.
So this is g of x.
This is no, it doesn't matter. G of x, f of x, k of x, chunk of x doesn't really matter. It's just a name. It's like Mr. Ye, John, the person. If you haven't failed, you haven't tried it. You gotta fail.
So you were looking for the derivative of g of x?
Yeah. What time I get out of here? Ever you done? No? Just tired? I rewrite this function so I can use chain rule. Did you do this? Did you do this? Negative 2, right? Because you got it moved up to become negative power, right? Now g prime of x, see how I write it? Now I know I'm taking derivative. Before I didn't take a derivative. Now it's going to be negative 7 times negative 2/3 times 2x minus 5 to the what? Negative what? No. Negative what? 5/3.
Oh, that's shit.
That's okay. Let it out. I don't want to give a shit. 28, I think. Over 3, right? Times 2x minus 5 to the negative 5/3. I can change it to on the bottom now. 28 over 3 times 2x minus 5 to the 5/3.
Why is it negative 7 times negative 2x?
What?
When you take the derivative, why is it negative 7 times negative 2/3?
Because you gotta bring that power down -2 in the front. That's to take it to the outer function. So you really think about it, it's actually this is the outer function, and this the inner function. So outer function is gonna be -2/3 times -7 times 2x minus 5 to the -5/3 because you gotta subtract 1 times the root of the inside. Most people forgot this. Any other power. So let's just say square. Every time I see a number, you start off first play. I'm gonna call you. I'm gonna get in call.
What they do, they send them to the page, and then they put that just physically there the page.
Or you gotta run away to the
So, yeah, so getting that is at least often.
That's back to uncoordinated. You don't realize.
Knowing where you.
It's not a big deal.
You need help.
It's like, yeah, I can see that. When you learn to walk with your baby. Keep on falling, and one day you finally get able to walk, and your mom's so happy about it. That's what I'm looking for.
Honestly, I've been back to school.
You better.
You know what? I got here at lunch and I had like a macro routine. I'm noticing that the homework for the past couple of days, and then also just from telling the lessons, I'm kind of losing my confidence in myself, and it's getting hard for me because I feel like I'm so behind.
It's tough outside.
To rest.
They're so long for no reason. Long.
Again.
Oh, I can't tighten them, bro. I need a rubber band.
I don't feel anything. Not just association.
Bro, I'm not making it.
I'll take my over.
I'm not making it.
We're gonna go on.
There's no way my shit.
I hate
You know class?
My class, I'm at school.
You in this class?
Where'd you go? Bruh, the beginning of the year, she was in law school.
What about all those?
Oh, no.
You're doing it at home? You're doing it at home? What is it? How much do they make? $80. Versus weekend. I'm watching 9 next to you. 7.
That's just the right thing. I forgot about the multiplication. Yeah, I did not have to.
It's really phenomenal. Dude, it's gonna fit the actual shape.
I hope I didn't get it up.
Well, you have friends, so click on phone too.
No.
You didn't get the I think it's pretty similar.
Wait, so it is one time? Like for the last thing?
Which school?
Oh, no school.
Huh? I think it's.
No, I've been
Yeah.
Yeah.
What year are you? Were you taking calculus before?
No, I was taking pre-calc.
Okay, I'll talk to you after.
So.
She had been.
Guidance playing me. What's your name? What's your name? Huh? You were school last year too. And you never show up to school. Okay, come sit here. We'll go through all that thing.
Man,